When most people think of the Cold War, they picture spies, missiles, and submarines gliding through dark oceans. But far from those flashpoints, a quieter battle unfolded. One fought not with weapons, but with the struggle to keep the lights on. Imagine a world so cold that fuel froze solid, where diesel turned to sludge, and batteries died in minutes. In the endless Arctic night, where the sun could vanish for months, small outposts still needed to run weather instruments, radar systems, and listening posts. Yet resupplying them was nearly impossible. Aircraft risked crashing in storms, and generators needed constant fuel. In that frozen wilderness, silence was survival, and power meant life itself. But somehow, buried beneath the snow, machines kept humming, quietly, endlessly, drawing their strength from something no one dared to touch. They didn't run on gas or sunlight. They were powered by decay, by the invisible heartbeat of atomic energy. This is the forgotten story of the Cold War's nuclear batteries, the small reactors that never needed refueling and outlasted the nations that built them. During the 1950s, as the United States, the Soviet Union, and Canada built the distant early warning line, a chain of radar stations stretching across the Arctic, they faced a near-impossible engineering problem. How do you generate electricity in a place where fuel cannot flow, batteries freeze, and the sun disappears half the year? Engineers began to dream of something radical, a power source that worked continuously, silently, and without human maintenance. The answer came not from the battlefield, but from the space race. While designing probes to survive the frozen vacuum beyond Earth, scientists created a remarkable device, the radioisotope thermoelectric generator, or RTG. Unlike a nuclear reactor, an RTG had no moving parts, no coolant pumps, no control rods. Instead, it relied on the steady heat produced by the natural decay of radioactive isotopes. That heat flowed through thermoelectric materials, metals that produced electricity when one side was hot and the other cold. In space, this was revolutionary. On Earth's frozen edges, it was perfect. The Arctic, with its bitter cold, became the ultimate testing ground. The greater the temperature difference between the radioactive core and the icy air, the more efficiently the generator worked. For the first time, it was possible to have a power source that could run unattended for decades. No engines, no fuel lines, no noise, just pure, continuous energy. Both sides of the Iron Curtain raced to deploy them. The Soviet Union scattered hundreds of RTGs across its vast, uninhabited coastline, powering navigation beacons, lighthouses, and meteorological stations along the Siberian seas. Some of these units, known as the Beta M and Gamma series, were left running for 30 or 40 years without a single maintenance visit. After the Soviet Union collapsed, many were forgotten, silent and dangerous, until scavengers stumbled upon them decades later, unaware that the heaters they were dismantling were powered by radioactive cores. In the West, the United States took a similar path through its SNAP program, short for Systems for Nuclear Auxiliary Power. These compact nuclear batteries were designed for satellites, deep-sea sensors, and Arctic outposts where even aircraft resupply was impossible. Each unit was hermetically sealed, capable of surviving crashes, fires, and sub-zero temperatures. They became quiet guardians of remote frontiers, providing steady electricity where nothing else could survive. Inside every RTG was a small pellet of radioactive material, often strontium-90 or plutonium-238, encased in heavy shielding. As these isotopes decayed, they released heat. That heat passed through thermoelectric converters, creating a constant flow of current. It was the simplest of ideas, a heat engine with no moving parts, and yet it was one of humanity's most enduring power systems. In an environment where traditional fuel froze and solar energy vanished, this simplicity was genius. To grasp the scale of the achievement, imagine a generator the size of a car battery, capable of running a weather station or communications relay for decades. It required no refueling, no repairs, and produced no noise that could reveal its location. In the Cold War, where secrecy and reliability meant everything, this technology was gold. Though many of these devices have since been dismantled or buried, the principle behind them remains alive. Every spacecraft that journeys beyond Mars, Voyager, Cassini, New Horizons, Perseverance, carries an RTG at its heart. They continue to hum in the silence of deep space, powered by the same science first tested in the frozen Arctic. Even today, remote ocean buoys and polar sensors still use modern descendants of those Cold War power cells, operating far from human reach. But the legacy of RTGs isn't just technological, it's philosophical. They represent an engineering ideal that feels almost lost today. Resilience through simplicity power that doesn't depend on weather, maintenance, or fragile infrastructure. Systems designed not to be cutting edge, but to be eternal. That mindset still guides modern off-grid engineers and survivalists. Safe, non-nuclear thermoelectric generators now mimic the same process, converting heat from wood stoves, compost, or geothermal vents into usable electricity. In a remote cabin, a handful of thermoelectric modules attached to a burning stove can charge batteries, power radios, or run LED lighting. Exactly what Cold War scientists once achieved with nuclear heat. It's a reminder that the best solutions are often not the most complex, but the most enduring. The Cold War's forgotten atomic batteries teach us that self-reliance doesn't have to be fragile. Energy independence can mean systems that run quietly for decades, with no fuel, no noise, and no attention, just the slow, steady heartbeat of science doing its work. So the next time you imagine the Cold War, don't just picture missiles and spies. Picture the silent stations beneath the Arctic snow, the faint hum of a generator that no one has touched in 50 years, the light glowing softly in an empty outpost, powered by a fragment of matter still releasing its warmth from a century ago. Because, in the end, the story of these little nuclear batteries isn't just about power. It's about endurance, ingenuity, and the quiet defiance of human invention against the coldest places on Earth. And long after the missiles rusted and the maps changed, those generators kept running, steady, silent, and eternal, proof that sometimes the smallest machines leave the longest shadows.